Hello everyone, I am Soumyashree Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, in this class, we will discuss strain transformation in case of principal plane. So, we know that the plane will be, one plane will be said to be as principal plane when there will be zero shear stress. That means the tau will be 0 here. Okay, tau is 0, that does mean shear stress is 0. So, we will term this plane as principal plane, right? So, in principal plane, the stress and strains present in case of principal plane will be termed as principal stress and strain. So, in our previous classes, while we are understanding about by using Mohr circle, we have already found out how to find out principal stresses. So, now how to find out principal strain? The process is very similar to the previous one, just there will be little bit changes. Here we are taking the x axis for what? Normal stress, that is sigma n, right? And the y axis is for tau, that is what? That is shear stress, right? In case of finding out principal stresses. So now this x axis will be termed as epsilon n, that is normal strain, and phi by 2, that is shear strain, right? Here sigma n is similar to epsilon n. So, while we are finding out the sigma n and tau, then we have the value of sigma x and sigma y and tau x and tau y. Similarly, here we will have epsilon x and epsilon y and also the phi 1 and phi 2 values if present. So, epsilon and epsilon x, similarly we will find out the point epsilon x and epsilon y values, then find out the radius, finding out the center point, and by using that we will draw what? The Mohr circle, right? So, now what? Similarly, the very similar process with finding out normal stresses and shear stress, and there will be only change, that is tau is equals to phi upon 2. Okay, there will be no changes, only tau is equal to phi by 2. So, now we know how to find out strain. Now, what will be the relationship between principal stress and strain? How to find out this relation? So, okay, here. Okay. So, in to find out principal stress and principal strain and their relationship, we know that we will need one 3D plane. So, in 3-dimensional plane, here it is sigma x and sigma y and sigma z. That means sigma x will be acting in this direction, sigma x, and here sigma y, and here sigma z, right? Similarly, there will be strain, that will be epsilon x, epsilon y and epsilon z. In our previous classes, while we are discussing about normal stress and strain, we have find out one relationship. Let's go to that relationship, that epsilon 1 is equals to 1 by E into sigma 1 minus mu into sigma 2 plus sigma 3, right? Again, epsilon 2 is equals to 1 by E sigma 2 minus mu into what? Sigma 1 plus sigma 3. and epsilon 3 is equals to 1 by E into sigma 3 minus mu into what? Sigma 1 plus sigma 2. Okay. So, if we just consider these three equations, now we have these three equations. Let's put these equations in case of biaxial stress. Okay, if there is presence of biaxial stress, what we will do? Okay, there is some little bit problem. Okay, let's do it here. Yeah. So, consider we know that if there is presence of what? Presence of biaxial stress, there will be only two stresses, like sigma 1 will be present and sigma 2 will be present. Let's take sigma 3 is equals to 0. Okay. So, like in our previous equations, here what we have? Epsilon 1 is equal to 1 by E sigma 1 minus mu into sigma 2 plus sigma 3. So, let's do all the sigma 3's as 0. Let's take these things as 0. So, now what we will have? So, we will have epsilon 1 is equals to 1 by E sigma 1 minus mu into sigma 2. Epsilon 2 is equals to 1 by E sigma 2 minus mu into sigma 1. And epsilon 3 will be 1 by E into what? Minus mu into sigma 1. Okay, let's visit the page. Here, minus mu into sigma 1 plus sigma 2. Sigma 1 minus mu into sigma 2, right? So, here we have what? Those values in case of biaxial stress. Biaxial stress, we are talking about biaxial stress. That means we only have sigma 1 and sigma 2. So, sigma 2 will be, let's, sigma 1 is equals to what? Epsilon 1 into E plus, okay, let's just solve it. Epsilon 1 into E is equals to sigma 1 minus mu into sigma 2. That means sigma 1 will be what? Epsilon 1 into E plus mu into sigma 2. Similarly, from this equation, we will have sigma 2 is equals to epsilon 1, epsilon 2 into E plus mu into sigma 1. Okay. We are having sigma 1 value and sigma 2 values. Now, if we put the value of sigma 1, this is our equation 1 and equation 2. If we put equation 1 value in case of equation 2, what we will have? Let's, by putting it, solve the equation. Put the value of equation 2 in equation 1. Okay, so we have the equation as this. Sigma 1 is equals to epsilon 1 into E and what? Plus mu into sigma 2. Mu into sigma 2 and sigma 2 was epsilon 2 into E plus mu into sigma 1. Okay, if we put the value of sigma 2 here, what we will have? Sigma 1 is equals to epsilon 1 into E plus mu into what? Epsilon 2 into E plus mu into sigma 1. Right? Now, sigma 1 will be epsilon 1 into E plus mu into epsilon 2 into E plus mu square into sigma 1. Okay. So, sigma 1 minus mu square sigma 1 is equals to, here E is in both sides, let us take it common, epsilon 1 plus mu into epsilon 2. Okay. Now take sigma 1 as 1 and 1 minus mu square, okay, is equals to E into sigma, sorry, epsilon 1 plus mu into epsilon 2. Sigma 1 will be what? E by 1 minus mu square, okay, into epsilon 1 plus mu into epsilon 2. Here we have the relation between what? Sigma and epsilon, that is stress and strain. Next, if similarly we put the value of equation 1 in equation 2, what we will have? We will have what? Here we have equation 1 and 2. Let's solve it. Solving it is not necessary, but you can put the values like sigma 2 is equal to E by 1 minus mu square, epsilon 2 plus mu into epsilon 1. But let's solve it and check it if it is correct or not. Sigma 2 is equal to epsilon 2 into E plus mu into, we can put directly sigma 1 value, that is epsilon 1 into E plus mu into sigma 2. Okay. So, sigma 2 is equal to epsilon 2 into E plus epsilon 1 into mu into E plus mu square sigma 2. Now, what we will have? Let's take common sigma 2 and 1 minus mu square will be here. And here if we take common as E, we will have epsilon 2 plus mu into epsilon 1. Okay. Now, the value of sigma 2 is with us here. Epsilon 2 plus mu into epsilon 1. Okay. Just you can recheck those two values. Okay. We have the relation between stress, strain, or you can say relation between principal stress and strain. Here sigma 1 is equal to E by 1 minus mu square epsilon 1 plus mu into epsilon 2, and here sigma 2 is equals to E by 1 minus mu square epsilon 2 plus mu into epsilon 1. Okay. Now, we are having the values of what? Stress, strain, and now in our next classes, by using these equations, we will solve some numericals and we will understand betterly. So, for knowing those things, stay tuned with the class. Thank you so much.